Okay, this is example number 2 on degeneracy in second order differential equations. I've split up the two different videos because I didn't want to make a mistake again. So we want to find the particular solution to d squared y by dx squared take away 60y by dx plus 9y equals 4e to the power of 3x. And it's a particular solution this time, so I need initial conditions. And that's when x equals 0, y is equal to 1, and also when x equals 0, dy by dx equals negative 1. Right, so let's start. So usual straightforward start. Your Ox equation, m squared take away 6m plus 9 equals 0. And again, we need to factorise it, and it's obviously a trinomial. So we're adding to make negative 6 and multiplying to make positive 9. So you've got 1 times 9, 3 times 3. And 1 plus 9 is 10, so it's not that. 3 plus 3 is 6, but I need to make negative 6. And then just double check. Negative 3 times negative 3 makes positive 9. And negative 3 plus negative 3 makes negative 6. So m take away 3, m take away 3 is equal to 0. So m take away 3 equals 0. M take away 3 equals 0. So that means that our values of m are 3 and 3. So as usual, this is the place where we need to make our first decision. And that is, what case is it? Now, they're both real numbers, but they're the same this time. So it's case number 2. So that means our complementary function, because remember we call it a complementary function because the differential equation is non-homogenous, and it is y equals ae to the power of 3x plus bxe to the power of 3x. Because remember, when the roots are the same, we have to throw in that extra x term into our complementary function. So next we need to look at our particular integral, which means we need to find our trial function. Okay, so as usual we go to our little table, and this is our table here. So as usual, you look at the right hand side of your differential equation, and the right hand side is 4e to the power of 3x, which means it's an exponential. So I go down and I see that this here is an exponential, and this is what I have to use. Remember, the number stays the same in front of the t or the x. So I'm going to be using ce to the power of 3x. But remember what we said in the last example, you've then got to compare that to your complementary function. And we see that this and this are the same term. And we can't have that. So that's not going to work. So we've put in an extra x. Right, and then again, compare that to your complementary function. As you see, these two terms are now the same. Because you've got the x, but obviously the constant at the front, or the number at the front would be different. So I can't use that. So that means I'm down at using y equals cx squared e to the power of 3x. I need to put in another x term. And that is now unique. And that's what I'm going to use as my particular integral. So, first thing, I've got to differentiate it. And unfortunately, just like the last one, is going to be the product rule. Because I've got a function with x in it, cx squared, and that's multiplying a second function with x in it, e to the power of 3x. So 1 dashed 2cx times 2 left alone plus 1 left alone times the derivative of that bit, which is 3e to the power of 3x. So dy by dx is 2cx e to the power of 3x plus 3cx squared e to the power of 3x. Right, now I'm going to have to differentiate it again. So d squared y by dx squared, but this time it's even more tricky because I see that's a product rule, because that's a function of x multiplying a function of x, and this is also a product rule because you've got a function of x multiplying a function of x. I'm going to put my product rule things in brackets. So I'm going to consider that 1 and that 2. So differentiate that, 2c, leave that bit alone, e to the power of 3x plus, leave this bit alone, differentiate the second bit, which again is 3e to the power of 3x. Right, then I need to do the same to this bit here, so that's going to be 1, that's going to be 2, so that's going to be 6cx, then leave the second one on, e to the power of 3x, plus, leave the first bit alone, like that. So that's what I'm going to get for my second derivative. So now all I need to do is tidy that up a little bit. So d squared y by dx squared is 2c e to the power of 3x plus 6cx e to the power of 3x plus 6cx e to the power of 3x plus 9cx squared e to the power of 3x. And as you can see, these two terms are like. So I'm just going to add them together. So I've got my y, which is that one there. Got my dy by dx, which is that one there. I've got my d squared y by dx squared, which is that one there. So as usual, we go back to our original differential equation, and we're going to substitute those values in. The original differential equation is d squared y by dx squared, take away 6 dy by dx plus 9y equals 4e to the power of 3x. Okay, I'm just going to substitute in those three terms, one for dy by dx, one for d squared y by dx squared, one for dy by dx, and one for 9. So that's 2c e to the power of 3x plus 12cx e to the power of 3x plus 9cx squared e to the power of 3x. Take away 6 multiplied by 2cx e to the power of 3x plus 3cx squared e to the power of 3x plus 9cx squared e to the power of 3x equals 4e to the power of 3x. Now what we're going to do is multiply all our brackets again and then somehow work out what the value of c is. Now I know this seems quite complicated and long, but all again it is differentiating using the product rule and then multiplying out brackets. Okay, so first term staying the same, and then I'm multiplying everything in that second bracket by 6, or negative 6. So let's take away 12cx e to the power of 3x, take away 18cx squared e to the power of 3x, plus 9cx squared e to the power of 3x, it's 4e to the power of 3x. So I've just multiplied out both of those little brackets there. Right, so let's look at cx squareds. So I've got 9cx squared plus 9cx squared is 18x squared. Take away 18cx squared means that all three of those terms cancel. I've got positive 12cx and take away 12cx, so those two cancel out as well. So I'm just left with 2c e to the power of 3x equals 4 e to the power of 3x. Again, same reason, these are the same on both sides. So 2c equals 4, so that means that c is just 2. So that means that our particular integral is y equals 2x squared e to the power of 3x. So we worked out what our particular integral was, or our trial function. We differentiated it twice, using the product rule twice. Then we wrote down our original differential equation, and we substituted in our values. Now you'll always find that your cx's and your cx squared should always cancel out, so you're just left with c and the number on the other side. You know this e to the power of 3x on both sides, you can think of that as a divide, or they just cancel, whatever suits you. And then 2c is equal to 4, so c is equal to 2. So, general solution is y equals, it's your complementary function, which is ae to the power of 3x plus bx e to the power of 3x, and then we've got our particular integral, which is 2x squared e to the power of 3x. Now, general solution is good, but it's not what the question was asking for. The question was looking for our particular solution. So that means we've got to differentiate this whole thing here. Now, obviously, I'm going to have a product row there, and I'm going to have a product row there. So, I'm going to start by writing this over here. So dy by dx equals, right. So this bit's going to become something normal, but I know I'm going to have a product rule in there, and I know I'm going to have a product rule in there if I can fit it in. Okay, we'll see what happens. So I'm going to let that be 1, that be 2, 1, and 2. So this bit is just going to be 3a e to the power of 3x. That's going to be b, if you differentiate that, leave the second bit alone, e to the power of 3x plus bx times, if I differentiate that, 3e to the power of 3x plus, differentiate that, 4x e to the power of 3x plus, leave that alone, and that is it differentiated. So same as usual, I'm just going to tidy everything up. 3a e to the power of 3x plus be to the power of 3x plus 3bx e to the power of 3x plus (4x) e to the power of 3x plus 6x squared e to the power of 3x. Okay, I'm happy with that. So that's just been differentiated. Right, so next we've got our initial conditions. Our initial conditions were that when x equals 0, y equals 1. So that means we're using our equation with y. Right, that's the equation y equals, so that's the one I'm going to be using. So that's 1 equals ae to the power of 0 plus b0 e to the power of 0 plus 2 times 0 squared e to the power of 0. Right, as usual, we know that e to the power of 0 is 1. So that means that's a, that's 0, that's 0. So a is just 1. Okay, so we're substituting in 1 in place of y, 0 in place of all of your x's in the general solution. Right, then our second one was when x equals 0, dy by dx equals -1. Right, so I'm just going to cover over that top bit. So my dy by dx is this function here. Right, so -1 equals 3a e to the power of 0 plus b e to the power of 0 plus 3b 0 e to the power of 0 plus 4 0 e to the power of 0 plus 6 times 0 squared e to the power of 0. Okay, so just substituting 0 in place of all your x's and -1 in place of your dy by dx. Hopefully that's clear. So again, e to the power of 0 is just 1, so that's going to give me 3a plus b, that bit 0, that bit 0, and that bit 0, because you're just multiplying by 0 here, multiplying by 0 here, and multiplying by 0 here. So -1 equals 3a plus b. But already worked out in the top half of the page that a is equal to 1. So -1, take away 3 times 1 plus b. So -1 equals 3 plus b, so b equals -4. Okay, so that means your particular solution okay, so we substituted in our 1, we got 3, 3 moves over, it becomes takeaway, so -1, take away 3 is -4. Right, so our general solution was ae to the power of 3x plus bx e to the power of 3x plus 2x squared e to the power of 3x, but I've worked out that a is 1, that's just a 1 in there, and that b is -4. So y is just equal to e to the power of 3x, take away 4x e to the power of 3x plus 2x squared e to the power of 3x. And you may see these answers written with e to the power of 3x taken out as a common factor at the start, but I'm happy enough with that as your final answer. Now, that question came from an advanced higher paper from about 3-4 years ago, and it was worth 14 marks. Now, it was one of the last questions in that advanced higher paper, and as we know, the advanced higher questions are the last questions in advanced higher are the most difficult. So it was the most difficult question in the advanced higher paper for that year. So what I would like you guys to try is some questions that are very similar to that. So this question sheet, and again this is on degeneracy. And what I would like you to try is find the general solution, not the particular solution. I'm not going to ask you to find the particular solution of something that's degenerate, like the last example. There's a lot of different steps in that, but I showed you an example anyway. So I want to find the general solution to d squared y by dx squared, take away 8 dy by dx plus 16y equals 6e to the power of 4x. Right, and what I would also like you to do is, and this is a lot more difficult, so that one there I would say is worth 12 marks. I want you to find the general solution to 4 d squared y by the x squared plus 36y equals sine 3x. Right? Now, this one I would give 15 marks for. Right? And I'm going to give you a clue with this one. You cannot factorise that. So you're going to have to use the quadratic formula and then see are the roots real or are the roots complex, and then deal with it from there. Right, what I will do is I'll put the answer sheet to these two questions up on Teams, or email it out to you if you'd prefer. But good luck with the questions, and if you've got any questions at all, please email me or put them on Microsoft Teams. Good luck, everyone.